So today we're going to talk about exponential functions versus recursive functions. Okay? Now, before you get confused, this doesn't involve writing really pretty again. It also doesn't involve saying bad words again. That's something different. Okay? Recursive is a kind of functions. No, a kind of function. Got it? What's the general form for exponential functions? A times b to the x. Yes? So here's the general form of recursive functions. Okay? It's just a different way to write exponential functions. Yes? Not necessarily exponential, but this is when we're talking about it. Okay? Yes, it is. So recursive functions, they tell you the first term when when x is 0. So does it make sense if x is 0, that should equal a? Because when x is 0 over here, anything to the 0 power is 1, and a times 1 is a. That took entirely too long. Just worried about you. Okay, we're good. All right. So when x is 0, f of the value of the function is a. You okay with that? Okay. F of n, that means what? Any term of the function. What do you need to know? The common ratio, right? And if I'm trying to find n, what is n minus 1? Isn't that the term right before it? If I was trying to find f of 5, right, the fifth term, wouldn't this be the fourth term? So I just need to know the term before it and multiply it by the common ratio, right? Guys, does that make sense? It does, doesn't it, right? Because if you're thinking about a table, if we're going down a table, we just multiply by the common ratio to get the next term down the table, don't we? Okay? So here's what I need you to be able to do. If I give you this function, y equals 6 times 3 to the x, I need you to take this exponential function and write it as a recursive function. So in this particular problem, f of 0 is going to equal what? 6. And f of n is going to equal what? Well, in this formula we call it r, right? The common ratio. Isn't it? Isn't it b? Because isn't b our common ratio? Remember when we did the worksheet looking at the tables? Isn't that what we figured out? So what is this? 3 times f of n minus 1. Done. I'm sorry, what I mean by done is that's the answer. Like that problem is finished now. And now I'm going to show you another example. Y equals, let's do 4/3 times 1/2 to the x power. So f of 0 equals 4/3. F of n equals 1/2 times f of, done. How many more examples of this do you need? You good? Now the one other thing I'm going to ask, okay? If you're looking at exponential functions, can you tell me whether they're growth or decay just by looking at the equation? Yes, you feel fairly confident in that, right? How do I know by looking at this equation if it's growth or decay? What is greater than 1? The b, right? Is this growth or decay? Growth or decay? Really easy to tell, right? Can you look at recursive functions and tell if they're growth or decay? Just as easily? Yes, right? Where am I looking? I'm looking for the R, right? Because we talked about a second ago that the B and the R are like equal, aren't they? So the same rules would apply just for the R, right? So if I'm looking for the R, it's living right here. Is this growth or decay? And is this growth or decay? So this is growth, this is decay, yes? Any questions about that? That's it.